It's a popular summer destination for families, but right now all entrances to Yellowstone National Park are closed.
Yellowstone National Park is known for its world-famous geysers and abundance of wildlife.
These hot springs around Yellowstone are potentially deadly. Using this thermometer, I'm getting a surface reading of over 140 degrees, but just under the surface, the temperatures top 200.
Yellowstone National Park looks peaceful, but underneath it is a supervolcano that erupts every 600,000 to 800,000 years, spreading ash everywhere. In 2017, a huge earthquake almost caused an eruption. Since then, there have been more earthquakes than ever. What is the government hiding about the dangers of Yellowstone? Let us uncover why it might be wise to stay as far away as possible from this potentially catastrophic supervolcano on the brink of eruption. A ticking lethal time bomb. So much material was expelled that entire mountain ranges crumbled and disappeared. This recent increase in earthquakes has scientists worried about a larger, more destructive event that could threaten human life. The Yellowstone supervolcano is a caldera volcano, discovered through satellite images in the early 2000s, shocking scientists with its vast size. What lies ahead for Yellowstone, and are we ready for its consequences? Yellowstone has been hit by hundreds of earthquakes recently. While most are too small to feel, they're still concerning. Most of these quakes happen along a hidden fissure from an eruption 2.1 million years ago, between Hebgen Lake and the Yellowstone caldera. These underground forces cause small tremors, reminding us of the potential for future eruptions. What if these small earthquakes turn into something bigger? Yellowstone National Park is located in the northwest corner of Wyoming and stretches into Montana and Idaho. It's the first national park in the United States, known for its diverse wildlife, geothermal features, different types of ecosystems, and rocky landscapes. Native Americans have lived in the Yellowstone region for at least 11,000 years, with organized exploration starting in the late 1860s. The park's geology, with its hidden fissures and underground forces, makes it both fascinating and dangerous. The park's northern region experienced an earthquake swarm, with over 3,000 minor quakes in just 3 months. This was due to the slight sinking of the Yellowstone caldera, showing the ongoing instability of the area. The restless caldera sometimes releases gas and steam, like volcanic burps, raising concerns about a more devastating event. As the Earth's crust stretches and pulls, microscopic cracks form, allowing volcanic fluids to move and create tremors. The rock along these faults is prone to sliding or breaking, releasing energy that causes shock waves through the surrounding area. The recent earthquakes are a reminder of the threat beneath Yellowstone. The supervolcano is a massive force, capable of changing the landscape and climate of an entire continent. The question isn't if it will erupt again, but when and whether we will be prepared. Scientists continue to monitor and study these tremors and the forces beneath the surface, while the world watches with concern, aware that the next big eruption could change our world in unimaginable ways. Yellowstone's geology makes it a place of constant activity. The underground forces are always shifting, creating small earthquakes that, while mostly harmless, are a sign of the power beneath. These small quakes are caused by the movement of volcanic fluids and the shifting of rocks along faults. When these forces build up, they can cause larger earthquakes or even eruptions. The park's geothermal features, like hot springs and geysers, are a visible sign of the volcanic activity beneath Yellowstone. These features are created by the heat from the supervolcano heating up underground water, causing it to rise to the surface. While these features are beautiful and attract many visitors, they are also a reminder of the powerful forces at work beneath the park. Despite the danger, Yellowstone is a place of great natural beauty and scientific interest. Its unique geology provides a rare opportunity to study volcanic activity and learn more about the Earth's inner workings. Scientists use a variety of tools to monitor the park, including seismographs to detect earthquakes, GPS to measure ground movement, and satellite imagery to observe changes in the landscape. Yellowstone's history is marked by cycles of volcanic activity. The supervolcano has erupted several times in the past, with each eruption shaping the landscape in dramatic ways. The most recent major eruption was about 640,000 years ago, creating the Yellowstone caldera we see today. This eruption was so powerful that it left a large crater and covered the surrounding area in ash. The supervolcano's eruptions are driven by the movement of magma beneath the Earth's crust. As magma rises, it creates pressure that can eventually lead to an eruption. The size and impact of an eruption depend on various factors, including the amount of magma and the strength of the surrounding rock. While scientists can't predict exactly when Yellowstone's next eruption will occur, they keep a close watch on the park, revealing a deep concern about its potential danger. They look for signs like increased earthquake activity and changes in the ground's shape, not because they can make exact predictions, but to try and prepare for what might happen. The rise in small earthquakes around Yellowstone isn't just an interesting phenomenon, it's a clear warning sign. Every tiny tremor is recorded, analyzed, and discussed, adding to the sense that something big could be on the horizon. The ground itself, which swells and sinks like a huge, uneasy creature, constantly reminds us of the volcano's unstable nature. Scientists, with all their instruments and theories, often feel like they're trying to interpret signs from a powerful force they can barely understand. Their research, though wrapped in caution and the hope of being prepared, often hides a deeper fear that a sudden, massive eruption could make all their efforts pointless. The advanced technology they use is impressive, but offers no certainty, only a feeling of partial control. The truth is, they are in a high-stakes situation where nature makes the rules, and they can only guess what might happen next. As they go through data and predict possible outcomes, there's an unspoken understanding that an eruption could change everything. The effects of such an event would be enormous, not just for the area around Yellowstone, but for the whole world's climate and ecosystems. Despite their best efforts to predict and prepare, the uncertainty remains strong. The real question isn't if Yellowstone will erupt, but when and whether we will be truly ready or just left to deal with the aftermath. Yellowstone's ground changes shape as the pressure beneath the surface builds up. These ground deformations are like the Earth's way of sending signals that trouble might be brewing. When scientists observe the ground rising or falling, it's a clue that molten rock is moving underneath. The landscape of Yellowstone, beautiful and serene on the surface, hides a powerful and unpredictable force just below. The history of Yellowstone is marked by periods of calm, interrupted by massive eruptions. It's like a sleeping giant that wakes up unpredictably. This history makes scientists particularly cautious, knowing that past patterns can offer clues, but they are never a sure thing. The massive eruptions that shaped Yellowstone thousands of years ago serve as a stark reminder of what the park is capable of. The impact of a major eruption would be felt far beyond Yellowstone. Ash could spread over large areas, affecting air travel, agriculture, and even global climate. The potential for widespread disruption adds urgency to the scientists' work. They are not just studying Yellowstone for academic interest, but because the stakes are incredibly high. Every new piece of data, every small earthquake, and every change in the ground's shape adds to the puzzle. Scientists are like detectives, piecing together clues to form a picture of what might happen. They know that despite all their efforts, they are still dealing with many unknowns. Their work is a race against time, trying to understand and prepare before Yellowstone decides to erupt again. While we can't control when Yellowstone will erupt, the hope is that by understanding the warning signs, we can mitigate the damage and protect lives. Scientists' vigilance and research are our best tools in this uncertain game with nature. But even with all their knowledge and technology, the power of Yellowstone remains a humbling reminder of nature's unpredictability. Yellowstone's potential for eruptions is a reminder of the dynamic nature of our planet. It's a place where the power of nature is on full display, offering both beauty and danger. As we continue to study and monitor this unique park, we gain valuable insights into the forces that shape our world. Next, let's explore the earthquakes that shape Yellowstone's landscape. The hidden quakes of Yellowstone's wild heart. Yellowstone National Park is renowned not only for its breathtaking scenery and diverse wildlife, but also for its frequent earthquakes. These tremors often come in groups known as earthquake swarms. One of the largest swarms occurred in 1985, with hundreds of earthquakes shaking the park's northwestern region. The most powerful of these quakes reached a magnitude of 3.9, underscoring the park's unstable geology. This geological activity is driven by two main forces: a volcanic system and a tectonic system. The volcanic system exerts pressure on the Earth's crust, while the tectonic system stretches the ground from east to west. This combination results in frequent earthquakes, hot springs, and potential volcanic eruptions. A significant earthquake with a magnitude of 6 struck the park. Due to its remote location, it caused minimal damage. However, the threat of larger quakes or steam eruptions remains a constant concern. Scientists analyze seismic waves from these quakes to create images of the magma chamber and the caldera, helping them understand the park's geological history. An extensive monitoring system tracks every tremor, providing data to predict and prepare for future risks. The Earthquake Hazards Program has been monitoring Yellowstone's seismic activity since 1973. Over this period, nearly 48,000 earthquakes have been recorded in the area, with only one reaching a magnitude of 6. These earthquakes are crucial for maintaining the park's hydrothermal activity. They keep underground pathways open, allowing hot water and steam to escape to the surface. Without these periodic earthquakes, mineral deposits could clog the cracks and channels, silencing Yellowstone's famous geysers and hot springs. A striking example of hydrothermal activity in Yellowstone is the Great Prismatic Spring. This large turquoise pool is surrounded by vivid rings of orange, yellow, and green. As hot water and steam rise from the spring, they deposit minerals, creating these stunning colors. If the small cracks and channels beneath the spring were to become blocked, this natural display would cease to exist. The Lava Creek eruption had a lasting impact, covering large parts of the continent in ash and changing the climate for years. This eruption created a caldera over 30 miles wide and 45 miles long, now home to Yellowstone Lake. Recent studies have shown that there are 2 magma chambers beneath the caldera. The deeper one is 4.5 times larger than the shallower chamber. These chambers, filled with molten rock, fuel Yellowstone's geysers, hot springs, and mud pots, making it one of the most geologically active places on Earth. Yellowstone has a long history of earthquakes, with records dating back to the early 20th century. In recent years, there has been an increase in the number of tremors, raising concerns about the possibility of a major eruption. While such an event is unlikely, it is vital to monitor the park's geological activity. The park precariously perches atop a tangled web of fault lines tied to a lurking supervolcano, a geological menace lying in wait. Earthquakes routinely ripple through this landscape as these fault lines groan and stretch, accompanied by the subterranean ballet of magma, water, and gas. Yellowstone's claim to fame isn't just its geysers and hot springs, but its distinction as one of the United States' most earthquake-prone regions. With a staggering 1,500 to 2,500 tremors detected annually, it's a veritable seismic hotspot. Yet the vast majority of these quakes are mere whispers, imperceptible to human senses, but diligently recorded by the Yellowstone Seismic Network, a vigilant array of about 50 seismometers. This network tirelessly monitors the park's restless underbelly, capturing the ceaseless tremors that speak of an ever-shifting, volatile underworld. The smallness of most quakes belies the constant tension below the surface, where the forces of nature are in a perpetual state of flux. It's a delicate balance, one that prompts a relentless watchfulness. The notion of living atop a geological powder keg becomes disturbingly tangible, with every minor quake a reminder of the potential for something far more cataclysmic. Yellowstone's seismometers act as the park's sentinels, their unblinking vigilance capturing the park's seismic sighs and grumbles. Each recorded tremor adds to the narrative of a land in constant motion, where stability is a mere illusion. The interplay of tectonic forces and the subterranean movement of magma weave a complex tapestry of geological activity, underscoring the park's dynamic and precarious nature. While the picturesque vistas and bubbling hot springs attract millions of visitors, beneath this facade lies a volatile reality that few pause to consider. The seismometers, however, offer no respite from this awareness, their data painting a stark picture of a land constantly under stress. These earthquakes, often in groups called swarms, have been a common occurrence. The largest swarm in recent history happened in 1985, with hundreds of quakes shaking the park's northwestern region. The most powerful of these reached a magnitude of 3.9, revealing the park's unstable ground. This activity is driven by two main forces, a volcanic system and a tectonic system. The volcanic system puts pressure on the Earth's crust, while the tectonic system stretches the ground from east to west. This combination leads to frequent earthquakes, hot springs, and the potential for volcanic eruptions. Now, we'll see how these quakes impact Yellowstone's hot springs and geysers. The supernatural forces shaping Yellowstone. A significant earthquake with a magnitude of 6 struck the park, though it caused minimal damage due to its remote location. However, the threat of larger quakes or steam eruptions remains. Scientists analyze seismic waves from these quakes to create images of the magma chamber and the caldera, helping them understand the park's geological history. An extensive monitoring system tracks every tremor, providing data to predict and prepare for future risks. A striking example of hydrothermal activity in Yellowstone is the Great Prismatic Spring. This large turquoise pool is surrounded by vivid rings of orange, yellow, and green. As hot water and steam rise from the spring, they deposit minerals, creating these stunning colors. If the small cracks and channels beneath the spring were to become blocked, this natural display would cease to exist. The Lava Creek eruption had a lasting impact, covering large parts of the continent in ash and changing the climate for years. This eruption created a caldera over 30 miles wide and 45 miles long, now home to Yellowstone Lake. Recent studies have shown that there are 2 magma chambers beneath the caldera. The deeper one is 4.5 times larger than the shallower chamber. These chambers, filled with molten rock, fuel Yellowstone's geysers, hot springs, and mud pots, making it one of the most geologically active places on Earth. The park sits on top of a network of fault lines linked to a buried supervolcano. Earthquakes happen as these fault lines stretch and as magma, water, and gas move underground. Yellowstone is one of the most earthquake-prone areas in the United States, with about 1,500 to 2,500 quakes detected each year. Most of these quakes are too small to be felt by people, but are picked up by a network of about 50 seismometers called the Yellowstone Seismic Network. Yellowstone National Park is not only a wonder of nature, but also a hub of geological activity. Earthquakes, often in clusters called swarms, are frequent in this region. In 1985, one of the largest swarms occurred, with hundreds of quakes shaking the park's northwestern area. The most powerful of these reached a magnitude of 3.9, showing the park's unstable geology. The activity is driven by a volcanic system that puts pressure on the Earth's crust and a tectonic system that stretches the ground from east to west. This leads to frequent earthquakes, hot springs, and the potential for volcanic eruptions. A significant earthquake with a magnitude of 6 hit the park, though it caused minimal damage due to its remote location. However, the threat of larger quakes or steam eruptions remains. Scientists study seismic waves from these quakes to create images of the magma chamber and the caldera, helping them understand the park's geological history. An extensive monitoring system tracks every tremor, providing data to predict and prepare for future risks. The Earthquake Hazards Program has monitored Yellowstone's seismic activity since 1973. Nearly 48,000 earthquakes have been recorded, with only one reaching a magnitude of 6. These earthquakes are essential for maintaining the park's hydrothermal activity. They keep underground pathways open, allowing hot water and steam to escape to the surface. Without these periodic earthquakes, mineral deposits could clog the cracks and channels, silencing Yellowstone's famous geysers and hot springs. Let's look at the ancient eruptions that formed Yellowstone's features. Seismic stories from Yellowstone. A striking example of hydrothermal activity in Yellowstone is the Great Prismatic Spring. This large turquoise pool is surrounded by vivid rings of orange, yellow, and green. As hot water and steam rise from the spring, they deposit minerals, creating these stunning colors. If the small cracks and channels beneath the spring were to become blocked, this natural display would cease to exist. The earthquake caused massive landslides, destroying roads and bridges and claiming the lives of 28 people. One of the most significant outcomes was the destruction of the Hebgen Dam, which led to a flood that overflowed the landscape and changed the course of the Madison River permanently. This flood created Quake Lake, now a popular spot for boating and fishing. The earthquake also had a profound impact on the geothermal features of Yellowstone National Park. Dormant geysers suddenly erupted in regular patterns, and hot springs and fumaroles became more active. In the aftermath of the earthquake, communities came together to rebuild and recover. This led to significant changes in building codes, emergency plans, and controls. Scientists at the Yellowstone Volcano Observatory and the University of Utah used advanced technology to monitor and reduce risks, providing real-time data to alert authorities to signs of impending volcanic activity. The Hebgen Lake earthquake is a clear warning of why we need to stay prepared and aware of potential dangers. Yet many people still don't take it seriously enough. Another significant earthquake hit in October 1983, this time in Idaho near Bora Peak, with a magnitude of 6.9. Although it wasn't as destructive as the Hebgen Lake quake, it still caused a lot of damage in Idaho and nearby states like Wyoming and Montana. The quake was shallow, so it shook the ground hard and damaged buildings and roads, especially in the town of Challis, Idaho. Many buildings collapsed, and the town's water and electricity systems were disrupted. This event showed that Yellowstone's seismic activity affects more than just the park itself. It also impacts the surrounding regions. In Challis, Idaho, the quake's impact was particularly severe. Many structures were reduced to rubble, and essential services like water and electricity were disrupted. This event demonstrated that Yellowstone's seismic activity is not confined to the park, but poses a threat to the surrounding regions as well. The damage extended beyond the immediate area, challenging the idea that these places are safe from the park's geological activity. The Bora Peak quake forced a re-evaluation of regional seismic risks, even though it was less severe than other quakes. Despite these warnings, many people still underestimate the potential for widespread damage. The quake revealed how fragile our infrastructure can be. In Challis, the disruptions were a harsh reminder of how unprepared some communities are for such disasters. Buildings that had stood for decades were destroyed in moments, showing how powerful nature can be. The quake's impact was far-reaching, challenging the idea that seismic activity is a localized issue. The Bora Peak earthquake's effects were felt beyond the immediate area, forcing us to rethink how we prepare for such events. It highlighted the interconnectedness of regional geological activity and the need for broader vigilance. The quakes remind us that we must extend our awareness and preparation beyond just the immediate vicinity of known seismic zones. We need to recognize the broader implications for surrounding areas and be better prepared for future events. Yellowstone National Park experienced another significant seismic event in 2017, with the largest earthquake occurring on June 16th, measuring a magnitude of 4.36. This quake was part of the Maple Creek Swarm, which began on June 12, 2017, and continued until October of the same year. During this period, over 2,475 earthquakes were detected near West Yellowstone, Montana. These swarms are common in the region and contribute to nearly half of Yellowstone's seismic activity. Researchers from the University of Utah, the University of Texas El Paso, and Yellowstone National Park conducted a study in November 2017 to explore the origins of the park's geothermal features. Their goal was to understand the underlying geological processes better and improve seismic monitoring. Finally, we'll examine the ongoing volcanic activity in Yellowstone today. The pulse of a lethal park. Yellowstone's volcanic system is driven by a mantle plume, a column of hot rock rising from the Earth's core, creating magma that fuels volcanic eruptions. The Yellowstone supervolcano, one of the world's largest, formed its caldera about 640,000 years ago. Ongoing seismic activity and ground deformation indicate that magma continues to move beneath the surface. Yellowstone experiences many small earthquakes each year, with many occurring in seismic swarms. These quakes, often unnoticed by humans, are important indicators of geological activity. The park's unique seismic landscape includes various geothermal features like hot springs, geysers, and fumaroles, all resulting from the underlying volcanic system. Old Faithful, the most famous geyser, erupts regularly, showcasing the park's dynamic geothermal activity. Despite assurances from experts that recent seismic activity doesn't indicate an imminent eruption, the possibility remains concerning. The potential for a catastrophic eruption at Yellowstone, with its vast caldera and significant geothermal activity, poses a daunting threat. Such an event would devastate the surrounding landscape, releasing lava flows, ash, and debris, potentially triggering a volcanic winter. This could disrupt global climate patterns, leading to food shortages and worsening environmental challenges. Efforts to monitor Yellowstone's volcanic activity are ongoing, with the Yellowstone Volcano Observatory playing a key role. This collaborative effort involves the U.S. Geological Survey, the University of Utah, and the National Park Service, using advanced technology to provide timely warnings. Despite facing logistical challenges, harsh weather, and limited resources, scientists continue to innovate and explore new methods to enhance monitoring and understanding of the volcanic system. The park's iconic bison also show unusual behavior before earthquakes, potentially serving as natural indicators of geological activity. Studying these behavioral changes could provide valuable insights into the interaction between wildlife and seismic events, aiding in predicting and preparing for future geological disturbances. By integrating wildlife monitoring into volcanic monitoring strategies, scientists can develop more comprehensive measures to protect both human and animal populations. Recent seismic activity in Yellowstone highlights the importance of ongoing monitoring and research. Scientists aim to enhance predictive capabilities and develop new technologies to better understand the park's geological processes. While challenges remain, the goal is to protect this unique and dynamic natural landscape and prepare for potential threats. The reality of Yellowstone's seismic history and the ongoing efforts to monitor its volcanic activity reveal a landscape constantly in motion. From the destruction of the Hebgen Dam and the creation of Quake Lake, to the impact on geothermal features and the rebuilding efforts by local communities, each event adds to the complex story of this iconic park. Scientists, equipped with advanced technology and real-time data, work tirelessly to understand and predict seismic events. The 1983 Bora Peak earthquake and the 2017 Maple Creek swarm underscore that Yellowstone's influence extends beyond its borders, affecting surrounding states and regions. The 1959 earthquake disaster, the creation of Earthquake Lake, and the increased activity of geysers like Old Faithful and Steamboat show a pattern of destruction and renewal. The establishment of the Quake Lake Visitor Center serves as a reminder of these events and their impact. Recent small earthquakes continue to signal the park's geological activity, linked to the movement of magma and gas beneath the surface. By studying past earthquakes and monitoring current seismic activity, scientists aim to predict future events and mitigate potential damage. The interaction between tectonic plates and the Yellowstone volcanic system creates a unique seismic landscape, with frequent small earthquakes and occasional larger ones. The 1755 Lisbon earthquake, caused by tectonic movement alone, offers a stark contrast to Yellowstone's mixed tectonic and volcanic influences. Yellowstone's volcanic system, driven by a mantle plume, produces magma that fuels eruptions. The supervolcano's caldera, formed 640,000 years ago, remains active, with magma movements detected by a network of seismometers. These tools provide essential data for understanding the park's geological dynamics and preparing for potential eruptions. The park's frequent small earthquakes, many occurring in swarms, are key indicators of geological activity. Geothermal features like hot springs, geysers, and fumaroles are also important signs of the underlying volcanic system. Old Faithful's regular eruptions highlight the dynamic nature of Yellowstone's geothermal landscape. Despite reassurances from experts, the potential for a catastrophic eruption at Yellowstone is a serious concern. Such an event would have far-reaching consequences, including lava flows, ash clouds, and a possible volcanic winter. This scenario could disrupt global climate patterns, lead to food shortages, and worsen environmental problems. Interestingly, Yellowstone's bison may help predict earthquakes. Their unusual behavior before seismic events could provide valuable clues about impending geological activity. By studying bison movements and integrating wildlife monitoring into volcanic monitoring strategies, scientists can develop more comprehensive measures to protect both human and animal populations. Recent earthquakes in Yellowstone underscore the need for continuous monitoring and research. Scientists aim to enhance predictive capabilities and develop new technologies to better understand the park's geological processes. While challenges remain, the goal is to protect this unique and dynamic natural landscape and prepare for potential threats. Yellowstone National Park is often seen as a place of natural beauty, but there's a less pleasant side to its story. Beneath its surface, the park is constantly shifting and changing due to seismic activity. Over the years, major earthquakes have caused significant damage, disrupting the peaceful image many people have of the park. Even the smaller movements, detected by sensitive instruments, show that Yellowstone is never truly at rest. Scientists work hard to keep track of these changes. They use advanced tools and collect a lot of data to try and predict when and where the next big earthquake might happen. It's not an easy job, and it often goes unnoticed by the public. These experts have to analyze every little tremor and shift in the ground to understand what might be coming next. Their goal is to prevent any potential disasters and keep the park safe for everyone. Despite their best efforts, predicting earthquakes is a tough challenge. It's like trying to guess when a clock will stop ticking. The presence of a massive supervolcano under Yellowstone adds even more pressure. If it ever erupts, the effects would be felt around the world, not just in the park. This makes the scientists' work even more important and stressful. They know that one wrong move or missed sign could have devastating consequences. The scientists working in Yellowstone are often overlooked and underappreciated. They spend countless hours monitoring the park, trying to understand its many changes. They know that nature is unpredictable and can be very dangerous. Even with the best technology and knowledge, they are always racing against time. The park's constant activity is a reminder of how powerful nature can be and how vulnerable we are in the face of it. Every day, these experts look at data from their instruments, hoping to find patterns that will help them make better predictions. They understand that their work is crucial, but they also know that they can only do so much. Nature will always have the final say. Yellowstone's ever-changing landscape keeps them on their toes, always preparing for the next possible earthquake or eruption. Visitors to the park often admire its beauty without realizing the hidden dangers. The serene lakes and majestic geysers are part of a land that is always moving. The ground beneath their feet could shift at any moment, causing chaos and destruction. The scientist's job is to anticipate these movements and protect the park and its visitors. Is Yellowstone's beauty worth the constant threat of catastrophic eruption? Share your thoughts in the comments. Like and subscribe for more intriguing insights into our planet's most volatile wonders.